Okay, we'll start our very first official video with some suggestions on how to read mathematics. The important thing that we should remember here is that mathematics books are different from, say, novels, right? So if you're reading a novel, you read from cover to cover, and you can read it in one go, perhaps, if the story is really interesting and so on. But typically, when you read mathematics, you really need to take your time. Don't expect that you understand or you get everything when you read the whole thing in one go. Sometimes also you don't really have to read cover to cover. You can dip in and out of a book, but typically when you're following a textbook, you do have to read. You do have to read from cover to cover, perhaps. And if you're doing this in a course, your lecturer, of course, will help you in terms of navigating the textbook. Okay, so another thing that you need to remember as well is that mathematics is rarely overwritten. There's very little decorative words, if you will. So everything that is written means something. So you need to also have that in mind. So I summarized some key points from the book on some main suggestions, really good suggestions, on how to read mathematics. Let's take a look. Okay, I have here some suggestions on how to read mathematics. The first one is read actively. Have pen and paper with you when you read. I will demonstrate how active reading looks like in just a moment. Then you should read in stages. Don't try and read theorem first and then try to read the proof immediately. It's sometimes better to get an overview of the text first. So you can start with definitions so that you can follow the theorems. And the first reading, maybe you should do that first and then you do the proofs later. So don't expect to understand the whole text in one go. You should read in stages, okay? Leave the details a little later. And finally, when you finish reading, you should write a summary to see that whether you understand the whole contents, or not. Okay, so now I will demonstrate how an active reading looks like. Okay, I have here an excerpt from one of our textbook in here at the University of Pretoria for our first year mathematics second semester for the science stream. Okay, so this part talk about lines and planes, and specifically in this definition, it's talking about parallel lines. Okay, so suppose you are now try to read this for the first time, right? And at this point, you were just introduced the definition of a line. Okay, so when you see something like this, right, and you know that this is the line that is going through points P and Q. So when you read this definition, as I mentioned earlier, you should have pen and paper with you to really understand what's going on here, right? So it says here that two lines are parallel. Line 1 is line through P and Q. Line 2 is line through A and B in R3. They're parallel if this holds, that P minus Q is equal to alpha times A minus B for some non-zero real number alpha. Okay, so when you read this, it's very helpful if you have pen and paper with you to perhaps sketch to see what's going on here, right? So suppose you have two parallel lines, right? So because this is in the purpose of understanding what parallel lines, we roughly know from school this is how it should look like, right? Then you have line 1 goes through P and Q, right? Of course, here's the direction vector is P minus Q, so it is that one, right? And then the second one, let's say A is here rather, and B is here. We put B a little bit further. There, maybe. And the line goes through B and A with this direction vector A minus B. Okay, so when you draw a picture, you see that these two vectors, right, are parallel. So really what this definition is saying is that P minus Q, if P minus Q is equal to alpha times A minus B, namely that these two vectors are parallel. So what are these two vectors? There are the direction vectors of your lines, right? If the direction vectors are parallel, then we say that the lines are parallel. Okay, I should probably also mention before I started this that at this point parallel vectors have been defined in the book. This is the difficulty when you take an excerpt and you don't see the whole book. Anyway, so this is maybe a very trivial example, maybe very easy example, but this helps me a lot when I'm studying mathematics, when I learn a new thing, to just sketch and see what the definition is trying to tell me instead of just reading this whole thing in one go. Sometimes sketching really helps me to understand what's going on here. Okay, so then at this point when you understand that definition of parallel lines means that their direction vectors are parallel, you really can recall this definition easily when you need it a little later. Okay, so have pen and paper with you when you're reading to help you understand the content a little bit better. Okay, I will now demonstrate how to read solution to an exercise, and maybe some of these pointers that I'm going to make will also be applicable to reading proofs. Okay, but still have in mind what I mentioned earlier, that we need to be active in reading and try to read in stages. Okay, so this is an example from the same lecture notes or course notes that we hand out to our our first year, second semester students in science stream. We have here, the question goes as follows. Let S be the sphere with radius √2 and center C with that coordinates. And there's a line L through these 2 points. With those coordinates, determine the points where L intersect S if such points exist. Okay, so if I'm presented with a solution in front of me, what I typically like to do is to identify things that are familiar with me. Okay, so the first sentence here is very helpful. It says that L intersect S at a point R if and only if R is in S and R is in L. Okay, so that's very helpful, right? The person who wrote this says that this is what we want, right? We want a point that is both in the sphere and on the line as well. Okay, then if I just skim through very quickly what's going on here, the first part, right, it's just saying that R is on the line. And the second part, I see this, the norm of R minus C, so the distance from R to C is √2. Therefore, R is on the sphere with radius 2. So sometimes what I would do is also something like this. So I know that this part is telling me that R is in L, and this part is telling me that R is in S. So that's the setup here, right? I haven't looked at the details yet. All right, and then I see that the next one, the next step, what the author is doing is to use square for this. Why is that? Because then you can use dot product. Okay, that makes sense. And then the rest, it seems that you just replace one of these R from the second equation with the R from the line equation, right? And then the rest is the solving. Okay, so I can maybe make a note here that all of this thing here is solve both equations. Equations to get T, and which will give you the points of intersection. Okay, so then you can start reading in details, right? You read in details. So you see, let's start from the beginning again. Therefore, L intersects S at R if and only if 2 things happen. R is in L. There it is. So there exists a T such that R is T times P plus 1 minus T times Q, and this is just computation. At this point, the author really skips some calculation, right? It doesn't put minus 2 and 2 there at P 1 minus 1 minus 1 there at Q. So there are some steps here that are missing, right? So there are details here of computation that are missing. You should check, right? And when you read this, remember to check. Sometimes somebody may make a mistake, or this is also good for you to check for your own sake, right? Exercise. Okay, so check the details, and then you can also say maybe missing details. I don't know what's what, and whatever annotation you like to say there, right? And then the next step, as we say earlier, the author put it in the fact that R is in S, and then it says it's convenient to replace the last equation with this, so squaring both sides, right? And I already mentioned earlier that when you first read it, you start asking questions. Why is the author doing this? But you know that once you deal with norms and dot products, right, you know that it's easier to deal with norm squared, right? Because norm squared, let me use different ink here, that norm of x squared is x dot product with x when you're in Rn, right? Okay, so that is easy. We can use dot product. This is the idea. And then the next step is that substitute 118 to 119, or basically try and solve for t, right? Because here R depends on t, R depends on t. That's what we want to find, right? So you replace that R there with that R, right? And then the rest also details, right? So I'm not going to do it here, obviously, how to check details. But from this point on, there's also details that are skipped, and you should also again check, right? Check details. Okay. So this is what you should do, and then you get to the solution here, right? The simplified equation here, and it says this equation has only one solution, namely t equals a third. Okay, so there's again missing details here, right? Namely solving this quadratic equation. At this point, I'm assuming that the author assume that the reader is used to doing school algebra, so this step is skipped, right? But if you're maybe a bit rusty, or you're not sure, or you're a bit skeptical, that's actually very good to be skeptical of what you read. Okay, so always check. Yeah. So again, here you should check that this is indeed the correct solution. So check again, right? And then finally, when you get that, when you agree that t is exactly a third, then you can get the final solution, right? Which is just simply substituting the value third into t times p plus t times, or 1 minus t times q, right, over there. And then you're done. Okay, so as you can see, when I read through this, I try to identify what the author is trying to do first, right? And then go through the details. Okay, so again, this is a very easy example, but if you use this technique and when you you're encountered with a new proof or a new something that you haven't seen before, it's probably good to identify things that you're familiar with and try to break down the seemingly intimidating text in front of you. Okay, so again, let me repeat the 3 things that we need to do. Read actively, use pen and paper, right? And then read in stages and write the summary. So at the end, it's nice to just write the summary. For instance, with this example, you can try and write a summary of of how to determine points of intersection. You need to find a point that is in both the line L and the surface S, or it could be also surface and surface, whatever it is, right? And the crux of this example, right? Okay. So again, I repeat: read actively, read in stages, and try to write a summary. Okay. Speaking of writing. This is a nice segue to the next video where we're going to talk about writing mathematics. I'll see you then. Thank you for listening.